Welcome to this presentation. My name is Steve Bartlett. I'm a technical marketing engineer in HPE networking, and I have two topics for you, and they both concern fast reroute technologies. And there's two features. One is released in 10.14.1000. This is BGP PIC for the CX 9300 series, and the other is in 10.15 for OSPF FRR for the CX 9300 series. And this is the agenda, quite a small set of topics. First of all, there's an overview of both features and the background of the technology. And then we go into BGP PIC with a bit more detail, and then into FRR with OSPF. And we finish off with the configuration examples, show commands, and scowl. Okay, let's go straight into the overview. So this is the overview. There's quite a few bullets on this slide, so I'll go through them as reasonably quickly as I can. So the first one, BGP PIC and IP FRR, are collectively referred to as fast reroute technologies. And with that, they allow routes to be configured with a primary and backup next hops. And the advantage is that the failover times are measured in milliseconds between the primary and backup next hop are reduced by at least 30% approximately. And these are the timings that we've had with a fully loaded system supporting the maximum amount of primary and backup next hop. So that's a conservative value. So BGP PIC is configurable with BGP, and IPFRR is enabled on OSPF. So collectively they are both independent features, but they both depend on BFD configurations on appropriate interfaces, but they can be configured independently. So just a note, only IPv4 unicast routes are supported today. And this is the first phase of the release. So the first phase is only providing support for the CX 9300 series platforms. VXX topologies are not supported with these fast reroute features, and that comprises of the 10.14.1000 release for BGP PIC and 10.15 for IP FRR for OSPF. So the OSPF routing protocol uses an RFC standard to achieve fast recovery. That's RFC 5286, and the BGP routing protocol uses BGP PIC. That's what it's known in the industry. And BGP PIC is currently an IETF draft document. So it is subject to change in future releases, subject to the draft then becoming into a formalized standard. So on to BGP PIC, a little more detail about this feature. So PIC standing for Prefix Independent Convergence. And as I mentioned, IP Fast Reroute, FRR and BGP PIC are both IP resilience technologies that provide fast traffic recovery upon a link or next hop failure. So in this topology here, we've got our core 9300 routers, core 1 and core 2, connecting to our CPE equipment, border router 1 and border router 2, which are then facing off to the internet. And between these border routers and our core, we're running BFD on the appropriate interfaces. And we've got primary next hop in green and the backup next hop in amber, and you can see each switch, core 1 and core 2 as a primary next hop for its uplink, going to border router 1 for core 1 and border router 2 for core 2. And routes are assigned primary next hops and backup next hops, and these are referred to as protected routes. So if we take this example here, we've got a route 201.0.0.0 and next hop on from core 1. This is an extract from the core 1 routing table, for example, is 20.20.20.2, and the backup next hop is 40.40.40.2, which is on CPE border router 2. So the primary next hops are programmed for traffic forwarding the data plane. If they are unreachable, the data plane is reprogrammed to forward traffic to the backup next hop. So these backup paths are pre-computed so that they can be activated as soon as a failure is detected. And then we get a very fast failover to the backup next hop. So routes that are not assigned with an alternative next hop are referred to as unprotected routes, also as native or ECMP routes. And as I mentioned, BFD has got to be enabled between our interfaces for this to work. We do not have support for VSX between the 9300s, as I mentioned previously, nor for IPv6. We've got a scale for VRFs up to 64. So the use cases for it is that reduces the data plane convergence times to accelerate failover times, and of course our benefit generally is we get faster failover. As I mentioned, we've got a minimum of 30% failover times in our testing. This was measured in milliseconds at the supported max route feature load. So if you've got under the feature max feature load for these features, then you're likely to get faster failover times. So this is all supported in 10.14.1000 BGP PIC for the 9300 series. So a little bit more on BGP PIC and the way it fails over. So same topology as the previous slide, 9300s, same routes, primary next hop route for core 1 and the backup next hop route. So if the BFD session fails from core 1 to next hop route 1, we've got this fast failover with the BGP control plane detecting the primary next hop 1 is down and failing over the routes to the new next hop, which is now of course on router 2. Now that's a fast failover, and for the failback, when this original route next hop comes up and it's in the RIB, the routing information base, the BGP control plane detects the primary next hop backup is back up and the primary is back up, and the fails over the route to the primary next hop. So we get back to our original state of play of the primary and the secondary next hop. But the failback is just based on standard convergence times with the routing protocol. So the fast failover is from primary to backup, not from backup to primary. So again, going through the support, BFD is required on both OSPF and BGP processes, but I'm just relating to BGP PIC here. Fast reroute features is the OSPF reference that we're using. VSX is not supported, IPv4 support only. We've only got this concept of primary and secondary next hop, no third or tertiary. ECM paths are not protected, so multipath is not protected. It's only primary next hop and backup next hop. And we've got this concept of each primary and backup next hop pair classed as a protected group. Maximum number of protected groups is 256, and we've got a protected route scale of up to 300k. And this is just a sample of the configuration for BGP PIC. It's just a one-liner. It's select best 2 is the new line, or the new added line to add paths. So for OSPF and IP FRR, I mean, the process is identical. We will have OSPF enabled point-to-point links, whether you're using routed only ports or a layer 3 ECMP, a layer 3 lag, sorry. You will need point-to-point links configured on the lag, if you're using a lag, or on the interface itself. So that's a prerequisite for OSPF, but we still need BFD between our, in this example, our core routers and our border routers for IP FRR with OSPF to work. So the principles are exactly the same. We've got the primary and backup next hops in the route table. So these will be OSPF derived routes, and everything is pre-computed. So under failure, we've got this fast failover from the primary backup next hop to the second, so the backup next hop, which will then be invoked. And then we've got the same fallback process should the primary path or the backup primary next hop be reinstated in the RIB. Then we fail back to the primary next path. So point-to-point links need to be used for IP FRR with OSPF. We've still got VSX not supported, no support for IPv6. Just do note that intra-OSPF routes only supported, inter-area OSPF routes are not supported. And again, we've got this feature supporting up to 64 VRFs. So a configuration summary. So if we want to enable IP FRR with OSPF, then under the OSPF instance, we type fast reroute. For BGP PIC, it's under the IPv4 unicast family, BGP add path select best 2 to enable FRR with BGP for the BGP PIC feature set. And these are examples of enabling BFD, this depending on the environment of where you want BFD to be enabled on, and this is a process of doing it for all interfaces for OSPF. So it's under the router process, enabling BFD globally, and then BFD all interfaces under the router OSPF processes. Likewise for BGP, BFD enabled globally, and under the BGP instance, you then enable for each neighbor fall over BFD. So on to some show commands. So this, first of all, BGP PIC protected. So this is one of 3. We've got show BGP IP unicast, and as you can see in the status codes, we've got a backup path, prefixed here is our primary path here with I, and the backup next hop for route 201.0.0.0/24 is on 40.40.40.2. Primary path is on 20.20.20.2. So the last command, show BGP IP unicast, showed all the routes in the BGP routing table. This command, show BGP IP unicast protected, will just give you the routes that are protected. As you can see, we've got one route protected that's installed, and next hop of 20.20, 20.2 for route 201.0.0.0, and it's got a backup next hop for the same route on 40.40.40.2. So with BGP, if you wanted more information relating to a specific route, in this case the example is on 201.0.0.0/24, and here it's giving you the next hop, backup and primary, along with all the relative BGP peering information as well, additionally there with using this command. So on to the OSPF show command. So first of all, there's show IP OSPF routes protected, and here we've got the primary next hop and the backup next hop highlighted. You can see that for these three routes on the left there, and likewise you can use the show IP OSPF routes protected all VRFs, and obviously you get information in the routing table for all the VRFs. Again, the format is the same with the backup next hop highlighted here, BKP. And finally, show IP OSPF routes protected VRF default, and that will give you all the protected routes in the default VRF. So on to the IP route command. So show IP route protected is also available for the RIB, and it will give you the originating protocol that's captured those next hop routes. In this case it's OSPF as the origin type for the FRR backup next hops, and they're prefixed here, you can see, with the plus sign, with the primary next hop at the top and the backup next hop with the plus sign underneath. And on the IP route commands, we've got show IP route protected all VRFs, and of course that will give us the primary next hop and the backup next hop for all VRFs. And for good measure, if you wanted to then get the output for a specific VRF, you can. And this example, show IP route protected VRF red, and it will provide the output for that specific VRF for the primary and the backup next hops. So a quick summary then of IP fast reroute with IP FRR and BGP PIC. So both fast reroute and with IP FRR and BGP PIC are IP resiliency technologies that provide fast traffic recovery upon a link or a next hop failure. The routes that are assigned primary and backup next hops are referred to as the protected routes to achieve fast traffic recovery. Routes are programmed with the primary next hop for traffic forwarding in the data plane. If the primary next hop for traffic becomes unreachable, the data plane is reprogrammed to forward traffic to the backup next hops. So backup paths are pre-computed so they can be activated as soon as a failure is detected. Routes that are not assigned with an alternate next hop are referred to as unprotected routes, and you'll see this in the documentation, all these terms. They're also known as native single ECMP routes. So BFD is used for quick detection to detect when the primary next hops are no longer available, so that it can trigger the fast failover mechanism. The OSPF routing protocol uses IP FRR, that's RFC 5286, to achieve fast recovery, so that's effectively a standard. The BGP routing protocol uses what's known as BGP PIC to achieve fast recovery, and BGP PIC is currently an IETF draft document, and with the draft it may be subject to change in future releases. So some prerequisites and deployment guidance. So just remember, IP FRR and BGP PIC as of 10.15 are only supported on the 9300 series. BGP PIC came with the 10.14 1000 release, of course, and IP FRR for OSPF came in on 10.15. BFD, bidirectional forwarding detection, must be configured on the primary next hops. That's on the between devices. OSPF point-to-point links must be enabled on OSPF next hops for IP FRR to compute protected routes. So if this is a routed uplink, that's a point-to-point configured on the ROP on the interface itself. If you're using a layer 3 lag, then you need to configure point-to-point on the lag itself. So that's for OSPF needing point-to-point links. So onto deployment guidance. So only egress interfaces for these types of interfaces, ROP, lag, which is layer 3, SVI, and sub interfaces are supported. Tunnel interfaces are not supported. Today we've only got support for IPv4 unicast. IPv6 is not supported. IPv4 multicast is not supported either. Protected routes can only have a single primary and a single backup next hop. So with OSPF IP FRR, it assumes both the primary and backup next hops are in the same routing area. This is a prerequisite for that. VSX topologies are not supported, and fast failover is not performed from the backup to the secondary, from the backup secondary to the primary next hop. So this is the fallback. So fast failover is only from primary to the backup next hop, not from the backup back to the primary, should that next primary next hop become available. It's then dependent on the standard convergence times of the routing protocol. So this is the scaling summary for BGP PIC and OSPF fast reroute. So we've got a maximum scale that we've tested with BGP PIC is 300k route scale with a 256 maximum primary and backup pairs. The optimum is 120, and with OSPF FRR we've got a route scale of 2000 routes with a maximum 256 primary and backup pairs with an optimum of 120. And just that reminder, only intra OSPF routes are supported with this feature for OSPF. And that's all I had for you today. And a quick reminder, if you haven't joined up to the Airheads community, the Airheads community is an online space for technical networking professionals, including customers, partners, and product and solution experts within HPE Aruba networking to support deployment, configuration, troubleshooting, and best practices, and sharing that information with you and our peers. Signing up for the Airheads community takes less than 2 minutes, and you can do it by scanning the QR code. So if you haven't yet joined, do so today.